Okay, we're continuing on graphing a system of inequalities. You may recall that the first thing we need to do is graph each inequality separately, and then we'll decide where the shading goes for both of them. For the first one here, I'm going to use my nice trick of finding the x and y intercepts by putting a 0 in for x. That means y would have to be 3. Let's make that in blue. And if I put a 0 in for y, that means x has to be 3. Okay. So I found the x and y intercepts quickly and nicely. And then I have to decide what kind of line will I draw, a dashed line or a solid line. This says greater than or equal to, and as you know, equal to makes a line. Okay. So here's the solid line. And finally, I have to decide which direction will I be shading this, down below it or up above it. Well, let's see. If I put 0 in for x and 0 in for y, that means I'm testing this point right there. Okay? I'm trying to see, does that point make the statement true? If it does, I'd better be shading that way. If it doesn't, I'd better not be shading that way. So let's test it. 0 in for x and 0 in for y gives me the statement 0 plus 0 is greater than or equal to 3. Well, that's not true at all. Okay? So I won't be shading toward this point. So I'll be shading away. And as you saw in the previous video, instead of actually shading for now, I'm simply going to make a little arrow that reminds me that's the direction I'll shade later. The second equation is simply y is less than or equal to 1. And you may recall that when it's just y equals a number or x equals a number, the lines are actually pretty straightforward. Okay? If it's y equals 1, that means I'm looking for all the points along here who have a y coordinate of 1. Okay? So all these points have a y coordinate of 1, so my line's going to go like this. Now, I do need to ask still, do I need a solid line or a dashed line? Well, it does say y is less than or equal to, and so if it's equal to, it would be a solid line. Okay. Now, less than, of course, is below, so this one will be shaded down. So where is the region where both of them will be shaded? Well, this one is shaded up here. This one is shaded down here. The place where both of them is shaded is right in here. So I will shade that like that. There's your solution. Okay. Let's look at another one. Okay. The first equation, I'll use my handy trick of if I put 0 in for x, that means my y is going to have to be negative 1, okay, because I get negative 3y would equal 3, and so y has to equal negative 1. So when you multiply by negative 3, you get 3. So y is negative 1. If I put 0 in for y, x would have to be 3. So I get those 2 points, and it looks like a slope of 1/3 up 1 right 3. So I'll just go down left here so I can have another point. And what kind of line do I need? Well, it doesn't say or equal to. It just says less than. Now, equal to would have a solid line, but it doesn't say equal to, so we'll do a dashed line. And some of you remember my little saying, if it takes more ink to make the sign, then it takes more ink to make the line. Okay? So that one's shaded. We have to decide which direction to shade that one now. If I put 0 in for x and 0 in for y, again, I'm testing this point right here, I get the statement 0 minus 0 is less than 3. Well, that's true. So I'd best be shading toward this point. So I'll make a little arrow here. Okay. The second one, if I put 0 in for x, I can find the y-intercept. That's going to be 2. If I put 0 in for y, I get, well, let's see. Negative 6 divided by 4 is, well, 1.5, I guess. So we'll just put that point right there, 1.5. Okay. And what kind of line will I need? Looks like I'll need a dashed line because it doesn't say or equal to. It just says less than. So we'll make a dashed line through there. And which way will that be shaded? If I put 0 in for x and 0 in for y, I would get the statement 0 minus 0 is less than negative 6. Well, that's not true. 0 minus 0 is 0, and that's not less than negative 6. So for the red line, I'd best not be shading towards 0, 0. It doesn't work. So I'll shade away from 0, 0. So now, again, we must find the region where both of them would be shaded. And sometimes I do this. I'll use shading in different colors. So I'll shade in blue. Okay. The part above blue, it kind of got a little sloppy, didn't it? So let's try that again. Then I'll use a nice little trick here. Get not so dark. Okay. I know, you don't get the fancy tools like that. In red, I'll shade this one. And I think I'll take that one and also get it up a bit. So now, where is it that both of these are shaded? Well, right in this region in here. So maybe I'll take my shade that. So that's the area where both of them are shaded. Now let's do one more. The first equation, first inequality, if I put a 0 in for x, what would I get? What do I have to have for y to get negative 2? Well, it's already negative, so if I put a 2 in for y, I get negative 2 equals negative 2. So 2 in for y works there. If I put 0 in for x, then I get x equals negative 2. So x equals negative 2 right there. And what kind of line will I need? Well, this one says less than or equal to, or equal to, it gives you a solid line, so we'll draw a solid line there. Okay. And let's decide which way to shade. I'll test the point 0, 0 again. If I put 0 in for x and 0 in for y, I would be getting the statement 0 minus 0 is less than or equal to negative 2. Well, that's not true. So I won't be shading toward that point. I'll be shading away. Okay. Let's graph the other one. Well, putting a 0 in for x gives me a negative 1 for y. But putting in a 0 for y gives me a 1/4 for x. And that's going to be kind of cramped in here. It's going to be a little bit inaccurate. So I think what I'll do is use a different strategy on that one. I'm going to subtract 4x from each side. This equation then will say negative y is greater than, instead of writing 1 minus 4x, I'm going to write negative 4x plus 1. And then I have to get that y away from, the negative away from the y. And the simplest way to do that is to multiply or divide everything by negative 1. Negative y divided by negative 1 gives you positive y. Negative 4x divided by negative 1 gives you positive 4x. Negative 1 divided by negative 1 gives you negative 1. Don't forget, though, because I multiplied or divided by a negative number, I have to turn the sign of the inequality around. Okay? A lot of people forget that. So that one, as we can see, does cross at negative 1. Then it has a slope of 4, so it will go up 4 and right 1. Okay? And since it says greater than but not equal to, then we need a dashed line through here. And finally, let's see where that one will be shaded. Well, it almost goes through the point 0, 0, but we can still test it. If I put 0 in for x and 0 in for y, I'd be getting the statement 0 minus 0 is greater than 1. Well, that's not true. 0 minus 0 is 0, which isn't greater than 1. So I'd better not be shading towards 0, 0. I'll shade away from 0, 0. So the question comes up again, where is it that both of them are shaded? The blue one is shaded up above here. The red one is shaded to the right over here, and the only place where they're both shaded is this small little spot right in there. Okay, hopefully that gives you a pretty good introduction to solving systems inequalities by graphing.